For advanced problems in momentum, question 7.3, this diagram shows a ball of a given mass heading towards a person's head actually, at a certain velocity from a degree, an angle, from the vertical. So, part A is asking us, what is the ball's momentum change of the player's head, from the player's head, obviously. So I split it up into two components. I did the x direction and the y direction. So to find the momentum change, we are given the initial velocity. So, and we are also given this angle from the vertical, and we are also given the mass right here. For the x direction, set up not conservation, change the impulse equation, and we could solve for the impulse of x. Please make note that the final momentum will be positive in these answers, and the initial will be negative as the ball is going that way. So I got the value 15.25, yeah, and then I did the y direction. So the final would be 0 because there's no momentum in the y direction now, and the initial will be a value. Once you get these values, I set it up in unit vector notation. You can set it up as the actual value with a given angle by using Pythagorean theorem and tan theta, inverse tan, to find the angle. So for part B now, they're asking if the collision takes 0.08 seconds, what is the force applied to the player's head? I set up the equation change in momentum equals force times time. This is your time, and I did this for each direction. F of x now, F applied, would be this answer divided by the time, and now Fy would be this answer divided by the time, since this is in the y direction, J, and this is in the x direction, I. And then this is your answer for the force applied on the player's head in unit vector notation. Again, you could do the same thing to find an actual value with a given angle.